Hello students, differentiation formulae for inverse trigonometric function. In the earlier page, we have learnt differentiation formulae for trigonometric functions. Here, inverse trigonometric functions. Look, inverse, sin inverse, cos inverse, tan inverse, like in the earlier page, d dx of sin x equal to cos x. In the same way, d dx of sin inverse x equal to 1 by root of 1 minus x square. d dx of cos inverse x, just minus is added for that, minus 1 by root of 1 minus x square. Tan inverse x, d dx of tan inverse x, 1 by 1 plus x square. d dx of cot inverse x, just minus for tan inverse. Secant inverse x, d dx of secant inverse x, 1 by modulus of x into root of 1 minus x square. d dx of cosecant inverse x, minus 1 by modulus of x into root of x square minus 1. Notice, in d dx of cosecant inverse x, minus 1 by modulus of x into root of x square minus 1. Look above. All the formulae are having 1 minus x square, root of 1 minus x square. Especially cosecant inverse x is having minus 1 by modulus of x into root of x square minus 1. Look the beauty. Sin inverse, cos inverse, just minus difference. Tan inverse, cot inverse, minus only. Secant inverse, cosecant inverse also minus only, but root inside the root x square minus 1. Only 3 formulae, if you learn properly, automatically 3 additional formulae are consolation prizes to you. Some more trigonometric formulae to keep in mind. See, trigonometric formulae is most important to keep in mind for this specific exercise. Sin 2 theta equal to 2 sin theta cos theta. Same equal to 2 tan theta by 1 plus tan square theta. These two are the formulae for sin 2 theta. In early classes, we have learned this. Again, I am reminding you. Without this, you cannot move with this chapter. Sin 2 theta equal to, good, 2 sin theta cos theta. Next one, 2 tan theta by 1 plus tan square theta. Cos 2 theta equal to 2 cos square theta minus 1. 1 minus 2 sin square theta. 1 minus tan square theta by 1 plus tan square theta. Cos square theta minus sin square theta. All these 4 formulae are getting equalized to cos 2 theta. Cos 2 theta equal to 2 cos square theta minus 1. Cos 2 theta equal to 1 minus 2 sin square theta. Cos 2 theta equal to 1 minus tan square theta by 1 plus tan square theta. Next, tan 2 theta. Values of 2 thetas we are reminding actually. Tan 2 theta equal to 2 tan theta by 1 minus tan square theta. Compare with sine 2 theta. It is just 2 tan theta by 1 plus tan square theta. This is 2 tan theta by 1 minus tan square theta. There is a comparison between sine 2 theta and tan 2 theta. Okay. Next, last thing to be noticed. ddx of sin x equal to cos x. We know. But ddx of sin y equal to cos y dy by dx. See, y is differentiating by x, ddx of y, sin y. In the above formula, ddx of sin x only. Look this, ddx of sin x equal to cos x, ddx of sin y equal to cos y dy by dx. This is enough to enjoy this chapter with great output. Best of luck.
Hello students, exercise 5.2. Before going to direct questions of this exercise, let us look at the three different rules: multiplication rule, division rule and chain rule. Multiplication rule, division rule and chain rule. These three different rules are there. First one, multiplication. Look at multiplication. Suppose that we are going to differentiate the product of two functions 1 and 2. Then the answer will be 1 ddx of 2 plus 2 ddx of 1. Similarly, second, division rule. Under this rule, if we are going to differentiate two functions, that is 1 by 2, the rule will be 2 ddx of 1 minus 1 ddx of 2 divide by 2 square. Look at this. Multiplication rule, 1 into 2. 1 ddx of 2 plus 2 ddx of 1. First and second is there. First ddx of second. Second ddx of first will be added with plus symbol. In division rule, ddx of 1 by 2 will be second into ddx of 1 minus, look at this, minus. In division rule, minus is there. In multiplication rule, plus is there. So second, differentiation of first minus first, differentiation of second, divide by second square. Take care. ddx of 1 into 2, first ddx of second plus second ddx of first. Multiplication. In division, 1 by 2, second ddx of first minus first ddx of second, divide by second square. Two rules clear? Now, third rule is chain rule. The third one is chain rule. In chain rule, we will get different gates. Suppose ddx of sin x is there, right? If you look properly, sine with x angle is given. So sine is the first gate, angle is the second gate. How to solve? Already learnt. ddx of sin x will be cos x. Now differentiation will go to second gate ddx of x, which will provide you cos x only. In the formulas, we are learning ddx of sin x equal to cos x. But suppose if ddx of sin 5x plus 2 is there, then same first gate and second gate. Look at the first gate, sin, ddx of sin will become cos, angle will be same 5x plus 2. Now differentiation will be applied to second gate, ddx of 5x plus 2, right? Now next step will be cos 5x plus 2. Look at this, ddx of 5x plus 2, it will give you 5 plus 2 is constant, already learned, ddx of constant is 0. The answer will be, this 5 will come at this place, 5 cos 5x plus 2. This is the answer using chain rule. Look at chain rule once. You can see here, there are two different gates, first gate and second gate. Sin become cos. Second gate 5x plus 2, using the formula d by dx of x power n is equal to nx power n minus 1. Using this formula, we have solved 5x plus 2 and the answer is 5. 2 is a constant, hence 2 became 0. Differentiation of 2 becomes 0. Now 5 is multiplied with this, hence it is 5 cos x plus 2. Okay. So using these three rules, multiplication rule, division rule and chain rule, we are going to solve the problems of exercise 5.2. Look at first question. The question is sin x square plus 5. The question is sin x square plus 5. Look at the first gate, second gate. Single function only. Two gates are there. Which rule? Excellent, Nana. Chain rule. Which rule? Chain rule. Now, go for differentiation. Sin x square plus 5. ddx of sin x square plus 5. Sin will become, very good, cos. Cos of x square plus 5. Apply the differentiation in second gate. ddx of x square plus 5. Excellent. Now we will get cos x square plus 5. From here, using the formula ddx of x power n. What? Exactly. Nx power n minus 1. Using the same formula, here n is equal to 2. So, ddx of x square will be 2x power 2 minus 1, which is 1, that is 2x, plus 5 is a constant, it will become 0. Then this 2x is multiplied with this function, hence we will write 2x cos x square plus 5. This is the final answer. Once you look at the page, look at each and every step. Simply gate 1, gate 2, open gate 1 and open gate 2. Okay, next we will go for question number 2. Look at the book. Question number 2. This question is cos sin x Sin x. By looking at this question, some of you will be confused. Which rule is this? Chain rule or multiplication rule? Look at this. This is cos of sin x. Sin x is an angle. There is no multiplication. Multiplication means cos x into sin x. Here 1 multiplied by 2. But here there is no cos x. It is cos sin x. Means cos is the first gate. Sin x is the second gate. Now we will apply differentiation. If gate is there means yes, use chain rule. Gate means use chain rule. Multiplication rule will not be used. So ddx of cos sin x. Now apply the differentiation on first gate. ddx of cos x is equal to, yes, minus sin x, right? So it will become minus sin x. Now apply the differentiation over second gate. So ddx of sin x minus sin x, ddx of sin x will become cos x. Exactly. This is the final answer. If you want to write in another way also, you can write minus cos x into sin of sin x. Both are same. Cos x is multiplied here also and multiplied here also. Both are same steps. So first and second question, both we have solved using the chain rule. Now come for the third problem. Look at the third question. Question number third is sin ax plus b. Which rule? Yes, same chain rule, because two gates are there, first gate and second gate. So ddx of sin ax plus b, sin will become, yes, cos ax plus b. Now apply the differentiation over second gate. ddx of ax plus b, it will become cos ax plus b. Now look here, a and b are constant. If there is no information given other than x and y, keep in mind, other than x or y, all are constant only. If there is no information given for alphabets other than x or y, all the alphabets are taken as constant. Now if you apply the differentiation over here, ddx of a into x, a will come outside, it will become dx by dx. Automatically answer will be a into 1, that is a. So look at this, ddx of ax will become a plus b is a constant number, so ddx of b is 0. Now since a is multiplied with this function, a will come out, a cos ax plus b. This is the final answer. Now we will go for the fourth problem. Let's look at the fourth problem. The problem is sec tan root x. Problem is sec tan root x. Now look at this. There are three gates. First gate, second gate and third gate. Don't get afraid. Simply you apply differentiation gate wise. First for the first gate, next for the second gate and next third gate. So ddx of sec already learned. ddx of sec theta is equal to, very good, sec theta, tan theta. Apply here. It will become sec theta place tan root x. So sec tan root x tan root x. Simple. This is the place of theta. So d dx of sec is sec theta into tan theta. Now apply the differentiation at the second gate, d dx of tan root x. Now sec as it is tan root x into tan root x d dx of tan. Yes, d dx of tan theta is sec square theta, that is sec square root x. Now differentiation will go to third gate, d dx of root x. Same as it is, sec tan root x into tan root x multiplied by sec square root x d dx of root x. Yes, look at the formula. D dx of root x is equal to 1 by 2 root x. So we have solved all the three different gates. Now you can write it in the simplest form like sec square root x sec tan root x tan root x divided by 2 under root x. This is the final answer. Look all the steps. Look properly all the steps. How first, second and third gates has been broken in this problem. Look carefully each and every step. Pause the video, look at it, practice it properly. Then come for the fifth problem. Question number 5. Sin ax plus b divide by cos cx plus d. Which rule? Yes, very good. Chain rule as well as division rule. Division rule, who we tell? Look at the back page. D dx of 1 by 2 is equal to, yes, 2 into d dx of 1 minus 1 into d dx of 2 divided by 2 square. Second, d dx of first minus first d dx of second square. So apply the formula here. Directly you apply the formula here only. Take numerator as first function, denominator as second function. Write second, that is cos cx plus d dx of first, that is sin ax plus b, minus sin ax plus b ddx of cos cx plus d divide by second square, that is cos cx plus d whole square. See, second ddx of first minus first ddx of second divide by second square. Now apply chain rule here. First to write cos cx plus d, apply here, sign will become, yes, cos ax plus b. Now going to second gate, ax plus b will become, yes, a. B will be 0 because of constant, ax will be a. Now minus sine ax plus b, differentiation of cos is, yes, also minus sine cx plus d. Apply the chain rule on second gate, c will come out. Divide by cos cx plus d whole square. Now go for simplification. Some more simplification, it will come like this: cos cx plus d, cos cx plus d, there is a, look, a is there, a will come outside, it will become a cos. Look at this ones. Here there is a, if a comes out, it will become a cos cx plus d cos ax plus b, minus, look here, 1 minus here, 1 minus here, if multiplied, minus minus will get cancel, so plus. Now c will come out, c sine ax plus b sine cx plus d, divide by cos cx plus d whole square. Look at this. Any doubt? Any doubt there? Look at all the steps together. Look at the first step, a and b, first and second function. Second, ddx of first minus first, ddx of second, divide by second square. On simplification using differentiation by chain rule, we came to this step. Look at the problem again. Look one by one all the steps. Okay. Now come for problem number 6. Whatever the question is, if you have command over the chain rule, division rule and multiplication rule, easily you can solve it. Sixth problem is cos x cube multiplied by sine square x power 5. Look at this. Cos x cube into sine square x power 5. So first into second is there, means multiplication rule. If ddx of first into second, answer will be first ddx of second plus second ddx of first. This is the multiplication rule. We'll apply here multiplication rule. Then ddx of cos x cube into sine x power 5 whole square. Look at this. Sine square a is also called sine a whole square. So here sine square, it become whole square. Take care. Sine square is sine a whole square. Now apply the rule. First, second function. So first ddx of second plus second sin x power 5 square ddx of first cos x cube. Now cos x cube, look at this, x power n x power n minus 1, it will become sin x power 5. Now sine is there, so sine will become cos x power 5. Now x power 5 is there, it will become 5x power 4. Look, here we are applying the chain rule directly. First applied over this square, then applied over sine, and then applied over the x power 5. Now plus sine x power 5 whole square, that is second function, d dx of cos x cube. So first apply over cos. Cos will become minus sine x cube. Now apply over x cube, it will become 3x square. Now simplify this. After simplification, here 2 is there, here 5 is there. 5 2 ja 10. 10 into cos x cube sine x power 5 cos x power 5 and x power 4. Look at this. Plus here minus and plus will be together. It will become minus of 3x square sine x power 5 whole square sine x cube. At last it will become 10 into x power 4, 10 x power 4 cos x cube sine x power 5 cos x power 5 plus and minus minus 3x square sine square x power 5 and sine x cube. This is the final answer for this question. Look at all the steps, one by one, step by step. If you are going to solve it, it will be easy only. Only chain, product and division rule to keep in mind. Now come for problem number 7. Seventh problem. 2 under root cot x square. Look at this. 2 into under root cot x square. Apply the formula. D dx over 2 under root cot x square. As we know that 2 is a constant, 2 will come out. So 2 d dx of under root cot x square. Already learnt d dx of root x is equal to 1 by 2 root x. So here cot x square you can assume as x. So 2 d dx of under root will be 1 by 2 under root cot x square. Now we will enter second gate, d dx of cot x square. Here 2 and 2 will be cancelled. 1 by under root cot x square. D dx of cot is d dx of cot x. Yes, minus cos x square x. Very good. So apply d dx over cot. The answer will be minus cosec square x square into, now this will go to second gate, d dx of x square. Next step, minus cosec square x square divide by root over cot x square. X square will become 2x. So final answer will be minus 2x cosec square x square divided by under root cot x square. This is the final answer. This answer is also correct only. In NCERT, if you are looking backside answer page, you will be finding different answer. Don't get confused. This is correct only. To prove that one, only trigonometric transformation has been done with this answer. Look how. Minus 2x. We know that cosec theta is equal to 1 by sin theta. That's it. So minus 2x divided by, here it is cosec square x square, it will become sin square x square when taken into denominator. Under root, you know cot theta is equal to cos theta by sin theta. So under root cot theta will be taken as cos x square by sin x square. Now sin will be sent upside, then the next step will be minus 2x under root sin x square divided by sin square x square under root cos x square. Now transformation is here. To get the answer of NCERT, or otherwise if in the question it is given that prove this as this, then only apply transformation. Otherwise you leave it. Answer here also correct only. Now to apply the NCERT transformation, multiply root 2 in denominator as well as numerator. So root 2 in numerator and denominator, as well as you multiply root of sin x square in numerator and denominator. See, this transformation based on your common sense, looking towards what is there in right hand side. To prove that, we have to make this transformation here. Now root 2 will be multiplied here. So minus 2 and root of sin x square into root of sin x square, it become, yes, sin x square. Root and root will be cancelled. Divide by sin square x square under root. Look, this 2 will come here. This sin x square will come here. And already cos x square is there in the under root. So now next step will be, we know that 2 sin theta cos theta already learnt is equal to sin 2 theta. Apply same formula here. Minus 2 under root 2x sin x square divided by sin square x square 2 sin theta cos theta. It will become sin 2 theta sin 2x square. Now look at this. 1 sin x square will be cancelled with 1 sin x square. The final step is minus 2 under root 2x divided by sin x square under root sin 2x square. Same answer as mentioned in NCERT textbook. NCERT textbook answer is this. If it is supposed this question is asked you to prove, only then this answer you should go to proof. Otherwise, at this place your answer is correct. Look at all the steps once. Pause the video. Look at all the steps. Now come to the next problem. Question number 8. Problem number 8. This is cos under root x. Now what to do with this problem? Very simple. d dx of cos under root x. First apply over cos. Cos will become minus sine root x. Now apply over second gate, that is root x. So minus sine root x, d dx of root x will be 1 by 2 root x. So answer will be minus sine root x divided by 2 under root x. This is the final answer. Look how simple differentiation is if you have proper command over the three rules: chain rule, multiplication rule, and division rule. Once again, revised multiplication rule. Multiplication rule, 1 into 2. If you are going to differentiate, answer will be 1 d dx of 2 plus 2 d dx of 1. Very good. Now, if d dx of 1 by 2, that is division rule. Here 2 d dx of 1 minus 1 d dx of 2 divide by, don't forget, divide by 2 square. So learn these three different formulas, three different rules. Look at all the formulas and enjoy writing the page, practicing this page. Best of luck.